Here we're looking at section 3.4, and our big essential question is how can you derive a general formula for solving a quadratic equation? So we've looked at solving quadratic equations by graphing them, and then we looked at factoring, and we've also looked at completing the square, but sometimes those are not the easiest way. So we, in this section, are going to learn about the quadratic formula, which will work on any quadratic. So our learning targets, first we're going to solve quadratic equations using the quadratic formula. Then we're going to be looking at what's called the discriminant to determine how many solutions that we have. And then we're going to solve some real life problems. So the first thing is we have the quadratic formula. So we always want to remember that we need to be in standard form, which is everything over to one side set it equal to 0. So then I have ax squared plus bx plus c equals 0. So my quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is something you must know. So if you start memorizing this, this is going to help you a lot. And this is something that should be memorized, so you can use it at any point in time. Okay, so here we're going to solve this equation, this quadratic equation, using the quadratic formula. The first thing I notice is I need to get everything to one side, so I'm going to subtract 5 from both sides. So now I have x squared plus 3x minus 5 equals 0. Well, now I have my a value, which is 1, my b value, which is 3, and my c value, which is a negative 5. So now I can use my quadratic formula. So negative b plus or minus the square root b squared minus 4ac all over 2a. Well, let's just plug in the information that we know. So I have a negative b, which is 3, plus or minus the square root of b squared, which was that 3, minus 4, times a, which was 1, times c, which was a negative 5. And using parentheses is a great thing to do when we're multiplying, so we can keep everything straight. All over 2 times that a value, which was 1. So let's continue to simplify. So we've got negative 3 plus or minus the square root of 3 squared is 9, minus 4 times 1 is 4 times a negative 5 is negative 20, all over 2. So again, we simplify our next step. So I have negative 3 plus or minus the square root 9 minus a negative 20 is 29 all over 2. So from here I look and I see that this is a radical that cannot really be simplified, so I can leave this as my final answer. So I have my two solutions, right? I've got negative 3 plus the square root of 29 divided by 2, and I have negative 3 minus the square root of 29 over 2. So those are my two solutions, which I can put into my calculator and get my estimates from there. So here are some for you to try using the quadratic formula. Make sure you get everything to one side first before you find your a, b, and c. So now here's a different one. We're going to use a quadratic formula. So again, I have values on both sides of my equation. So I need to subtract my 12x from both sides. So 25x squared minus 12x minus 8x equals negative 4. Well, I can simplify here. So 25x squared, negative 12 minus 8 minus 20x equals negative 4. So now I need to add this 4 to both sides. So 25x squared minus 20x plus 4 equals 0. So now that I've got everything over to one side, I can use my quadratic formula, which again, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now I can just plug in the things that I know. So I have a negative b, which is that negative 20, plus or minus the square root of b squared. Let me make that a little bigger. Minus 4 times a, which is 25, times c, which is 4, all over 2a, which is that 25. So now I can continue to simplify what I'm looking at. So the first thing I simplify is I see I have a negative of a negative, such it becomes 20 plus or minus the square root of negative 20 squared is a positive 400, minus 4 times 25 is 100 times 4 is 400, all over 2 times 25 is 50. So this I see becomes 0 because 400 minus 400 is 0. So 20 over 50, which x now equals 2/5. So you see here I only have one solution. So we can always double check this by graphing it and see where we end up. So don't forget that solutions are where the graph crosses my x-axis. So here it only crosses once, so this also tells me the vertex of my quadratic equation. So now here's our next one. Solve negative x squared plus 4x equals 13. Again, I need to get everything to one side. So I start by subtracting 13. So negative x squared plus 4x minus 13 equals 0. So now let's use our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So then I can plug in my values. So I have a negative b, which is that 4, plus or minus the square root of 4 squared minus 4 times a, which is a negative 1, times c, which is a negative 13, all over 2 times that negative 1. So we can simplify. So I have negative 4 plus or minus the square root of 16 minus, and now I have 4 times a negative 1 gives me negative 4, times a negative 13, which gives me a positive value. And I don't, off the top of my head, know 4 times 13. So 4 times 13 is 52 over negative 2. So here I see I have a negative 4 plus or minus the square root of 16 minus 52. So again, we can use our calculator if we need to. So I've got 16 minus 52 is a negative 36 over this negative 2. Okay, so now let's simplify. So again, I see here I have this negative inside my radical, and this is where our complex solutions come in from earlier in this chapter. When I'm taking the square root of a negative number, I have to include that I. So I have negative 4 plus or minus I times the square root of 36 divided by negative 2. Well, this I know. I know the square root of 36, so I have negative 4 plus or minus 6i over negative 2. Well, let's simplify this a little bit more. So I see every single piece can be divided by this negative 2. So I've got negative 2 goes into negative 2 one time, negative 2 goes into negative 4 twice, and negative 2 goes into 6 negative 3 times. So I have 2 plus or minus a negative 6i. Oh, I'm sorry, negative 3i once I've simplified it. And that will be my final answer right there. Okay, so again, here are some for you to try. See if you can figure out how many solutions you have too. Because that's what we're looking at right here. We're looking at the discriminant. Okay, the discriminant is this b squared minus 4ac. And if you look back at the quadratic formula, you'll see that this is what's underneath the radical sign. So that's how we can remember this. So if I find the value of my discriminant, if my discriminant is greater than 0, that means I have my 2 real solutions. That's where it crosses twice. If my discriminant equals 0, I have 1 solution. And if my discriminant is less than 0, right, that's where I end up with some imaginary solutions. So I never actually touch the x-axis. So let's look at the discriminant here. And I've got my b squared minus 4ac. That's my discriminant. So I can plug in the values, which my b is negative 6 squared minus 4 times a is 1, c is 10. So I have 36 minus 40. This is a negative number, so that tells me I have no real solutions, but I have imaginary. So I know I have imaginary solutions there. So now let's look at this one. So again, I have b squared minus 4ac. So b squared is at negative 6 squared minus 4 times a, which is 1, times c, which is 9. So here I end up with 36 minus 36, which is 0. So this tells me I have 1 solution. Now let's look at this final example. So I still have my b squared minus 4ac. So b squared is this negative 6 squared minus 4 times a, which is 1, times c, which is 8. So I've got 36 minus 4 times 8, which is 32, which gives me a positive number, right? It doesn't honestly matter what this value is, just as long as it's positive. This tells me I have 2 real solutions. So I can always use the discriminant to just quickly tell me how many solutions I'm dealing with. So now here's some for you to try. See if you can just tell me how many solutions are there. Okay. So now we can also take this equation, just our standard form, and see and figure out what we're looking at. So here I'm finding a possible pair of integer values for a and c so that the equation ax squared minus 4x plus c has 1 real solution. Then write the equation. Well, since I'm told how many solutions I'm dealing with, I know I'm going to want to use the discriminant. So that's the first thing I do is I set my discriminant equal to 0. since I want one solution. Well, now I can plug in my b squared because that's what I'm given. I substitute that -4 for b. I end up with 16 minus 4ac. So then I want to get this ac by itself. So I subtract 16 and then I divide by -4. So here I see any combination, any pair where a and c multiplied together equals 4 will give me one solution. So there's several possible answers. So a could be 1 and c could be 4. So that would actually work out. There are multiple solutions, so this is just one possible way that we can get there. So now I want you to try it with this one and see what you can come up with. So there are different ways that we can solve quadratic equations. Okay, so let's talk through these real quick. So graphing can be fairly simple if I have a graphing utility. It's also handy if I just need approximate solutions. If I need exact, then graphing may not get me what I need. So I can use the square roots if I don't have that x term where I only have the squared and the constant. That's when I would go ahead and use square roots. So factoring I generally want to use when I have an a value of 1 or when I can just factor easily. I like to complete the square. This can actually be used for any equation, but it's easiest when a is 1 and b is even, because then I end up with simple numbers. The quadratic formula is good for anything, so we can always keep that one in mind when we're solving. Okay, so now we're looking at these real life problems. So we've looked at when we've dropped objects before. So now we're going to be looking at when we launch or throw objects. And the big difference here is I'm still using this -16t squared. I still have my initial height, but here's where it changes. I have a change in velocity. Okay, so I have to include that initial velocity, which is in feet per second. And just remember that we can have a positive velocity that's going up, we can have negative velocity that's going down, or our velocity can be constant. So we're going to look at some examples with this. So I have a juggler that tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial velocity of 30 feet per second. The juggler catches the ball when it falls back to a height of 3 feet. How long is the ball in the air? So the first thing I want to do is figure out what my equation is, and then I can solve for when h equals 3. Okay, so first I write my height model, and I know I'm going to use this because I have a ball that's thrown, not just dropped, and then I substitute what I know. I know the initial height, and I know the initial velocity. Here I want to also substitute in 3 for h, because I'm trying to find what the time was when it was 3 feet high. So I can do that as well. So now I'm going to write this in standard form, get everything over to one side of the equation. This to me is not an easily factorable one. This also would not be easy to complete the square, so I would use the quadratic formula. So I plug in all of my values, my a, b, and c, and then I just continue to simplify. So once I get here, since we're looking at time in an actual real world problem, I go ahead and I use my calculator and I look at my two results. So I see I have a negative solution here. This does not make sense because we're talking about time and I can't have negative time. So my solution would be this 1.9 seconds. That's how long the ball is in the air before it hits the juggler's hand again. So now I want you to try this one. So what happens if I change the initial velocity? Does that change how long the ball is in the air? Right? See if you'd think it would take longer or if it would take less time first. So let's look back at our learning targets. So first, we solved some quadratic equations using the quadratic formula. And over here, this is something you do need to memorize, so get working on that if you don't already. Then we looked at the discriminant, and this discriminant tells me how many solutions I have and what type of solutions they have. Then we looked at some real-life problems involving initial velocity and height with throwing objects. And that's generally where we're going to be going, is we're going to be looking at a lot of examples where we throw objects or hit a ball with a bat, those kinds of things. So now that we've gone through these learning targets, go ahead and work on your homework for this section.